Hello, welcome to Human Anatomy Prep. I'm Ty Gardner and I'll be your instructor. Okay, two mind maps. Let me explain. We have a mind map for the brain. It focuses on the main regions and discusses some of their parts. We also have a mind map for the meninges. These membranes surround the brain, but also the spinal cord. We'll cover these from superficial, just deep to the bone, to deep, just superficial to the brain or spinal cord. Let's begin with the meninges, the three layers of connective tissue membranes surrounding the CNS. This is a coronal section of the head, with the skull, cerebral cortex, and cerebral medulla visible. This allows us to see the layering of the meninges and the spaces associated with them. As suggested, we'll work our way in from superficial to deep. Superficially, between the bone and the dura mater, we find the epidural space, but I can't point to it here. There is no space between the dura mater and the skull, unless you bleed into it, an epidural hematoma. We often refer to the epidural space in the cranium as a potential space. It isn't a space, but it can become one. In the vertebral canal, fat fills a real space that is used for injections outside the meninges. Epidural anesthesia, sometimes given prior to childbirth, numbs dorsal roots in this area. We don't want to confuse an epidural with a spinal tap, where you would pull CSF from a space within the meninges. Deep to the epidural space, in contact with the bone in the cranium, is the dura mater, equals tough mother. The vertebral canal has one layer of dura mater, but the cranium has two. Blood vessels, dural venous sinuses, run between them in some areas. Deep to the dura is the arachnoid mater. They are in contact with the potential subdural space between them. Between the arachnoid mater and the pia mater is the subarachnoid space. This is a real space. In the subarachnoid space, we can see the spiderweb-like trabeculae that give the arachnoid mater its name. The pia mater is the deepest meninx, singular of meninges, laying on the surface of the cerebral cortex. Formed by ependymal cells, CSF, cerebrospinal fluid, flows through the subarachnoid space, allowing the brain to float and helping with the exchange of nutrients and wastes. After circulating through the brain and spinal cord, CSF returns to our blood through the arachnoid granulations. You'll learn a bit more about CSF in your anatomy and physiology classes. Okay, having learned about the membranes, meninges, and fluid, CSF, that surround the brain, let's look at the structure of the brain itself. The largest and most superior part of the brain is the cerebrum. It has 5 lobes, 4 labeled here. Deep to the cerebrum, the diencephalon, equals through brain, passes signals to and from the cerebrum. It also controls autonomic and endocrine function. Below the diencephalon, the brainstem connects the brain to the spinal cord. The cerebellum, hanging off the back of the brainstem, is associated with balance. The cerebrum has 2 hemispheres, left and right, separated by a longitudinal fissure. The cerebrum has 5 lobes, located near the bones they share names with, each with certain unique functions. The frontal lobe produces motor impulses, including speech, and provides personality and consciousness. The parietal lobe processes somatosensory input from the body, for example, touch and pain. The temporal lobe processes information related to hearing and smell. The occipital lobe processes visual information. The fifth lobe, the insula, seems to integrate physiology and psychology and is found deep in the lateral sulcus. The diencephalon has three main parts: the thalamus, the hypothalamus, and the pineal gland. The thalamus is a distribution center for sensory information coming from cranial and spinal nerves. The hypothalamus is the control center of the ANS and endocrine systems. It also controls drives like thirst. The pineal gland is an endocrine gland associated with circadian rhythms, day-night cycles. The brainstem also has three main parts: the midbrain, the pons, and the medulla oblongata. The midbrain relays visual and auditory information and orients the eyes towards stimuli. The pons has autonomic functions, for example, initiate REM sleep, and is the main connection to the cerebellum. The medulla oblongata has autonomic functions, for example, breathing and heart rate, and connects to the spinal cord. The cerebellum is located on the posterior and inferior side of the brain, connected to the brainstem. It coordinates motor output, for muscle movement, with sensory information about balance and limb position. This allows us to do things like maintain posture and walk on uneven ground, any coordinated movements. I hope this has been helpful. Your next stop is the video on cranial nerves.